Welcome back. So we have learned about the equivalent capacitance. Now let's have a look at the inductance. So the inductance calculations are very easy and the same approach of resistive network is applied. What does this mean? If we have inductors in series, you will just add them together, okay? Like we typically do for the resistive network. Like if we want to find the net inductance, so that will be basically L1 plus L2 plus L3. If the inductance are in parallel, the same resistive approach, like 1 over L1 plus 1 over L2 plus 1 over L3 and beyond, okay? So simple calculation for the inductors are same like the calculation for the resistor in terms of equivalent resistance or in terms of equivalent inductance. For the capacitance, it just become opposite like we just did in the previous cases. So let's have a look at an example now, okay? So now for this case, all inductors are basically 4 millihenry and we need to find out the net equivalent inductance between these two nodes. So approach will remain same. Okay, what we will do, we will just, let's for example, this is 4 millihenry, 4 millihenry. I'm not putting milli just to write, but this. The second thing is label the nodes. Okay, do the labeling. Like this is node 1, let's call this A. This is the second node, right? B. But remember, like this node is basically what? This is the same node, right? This whole thing is just a straight line. Then we have this node, which is basically C, and then we have this last node, which is basically D. Okay. All right. Now, if you look at this circuit, of course, we need to start from the end, but we need to find out the pair. Okay, a pair of series or parallel. So if I look at this circuit, I can see that basically this is connected at node A, like these are sharing node A, but this 4 and this 4, they are not sharing the second node, right? This is connected, this 4 is connected at B, this 4 is connected at C. So these two are not in parallel. But if I look at this one, okay, this one, so this is connected between B and C, and this is also connected, basically this is sharing node C here, and the second node, this is basically B. They are sharing the same node, right? Number one. So what does this mean? This mean is I can say that the combination of, okay, these two, like this one and this one, they are in parallel, right? So parallel 4, parallel with 4 will give me basically 2 millihenry. Okay, so if I redraw the circuit from the top, okay, I have here 4 millihenry. Okay, I have here this one 4 millihenry. Okay, this is node A. Okay, and this was a node B. Okay, and this was basically my node C. So between node B and C, what I got, 4 and 4 become basically parallel. So 4 parallel with 4 basically become 2 millihenry. So that I will put an inductor of 2 millihenry between node B and C, okay, because they are in parallel. Now let's have a look at the next thing. At the same point, we can notice that, okay, there is an inductor of 4 which is connected between B and D, okay, this one. Also this one, this is also connected at B because same node and D. So it means this one and this one, they are also in parallel. So 4 and 4 parallel again will give me 2. But this 2 is connected where? This is connected between B and D. So this is my B, okay, and that will be my D. Okay, so this 2 millihenry will come here. Why I put it here? Because this is connected between B and D. So 4 and 4 parallel become 2 here. Okay, so this circuit can be simplified to this form. Now further we can do it more easily. Okay, we notice that basically this 4 and this 2, okay, they are in series. So 4 and 2 become 6, right? So this 4 and 2, that will become basically 6 millihenry. Then this 6 millihenry, okay, if I redraw this circuit, so this will become basically 6 millihenry. Then I have here 4 millihenry, and then here I have basically 2 millihenry. So this equally 6 and 4, that will become in parallel. Okay, so if you look from this end now, 6 parallel with 4, okay, then whatever we get, that will be in series with this plus 2 millihenry. So that will give me basically 4.4 millihenry as the net. So L equivalent from this end, that will become basically 4.4 millihenry. Thank you so much.